Hey everybody, welcome back. This is Math 35 at College of the Sequoias, which is college algebra. At your school, it may be different if you don't attend College of the Sequoias. But this is college algebra is pretty much the same everywhere. You might have a different section number. What we're working on today is absolute value equations. And in our book, that is section 1.8. So let's just, what are absolute values? Let's say the absolute value of x equals 2. -2, if I take the absolute value of it, that equals 2. And the absolute value of +2 equals 2. The absolute value of x equals 2 is x equals 2 or -2. Okay, on a number line. That's a dead green pin. I've got 0 in the middle, -2, +2. I got a point there and a point there. Okay, those are absolute value equations. Not a big problem. They're pretty simple. You might have a different value inside, but you're still doing this. We want to, let's look at absolute value inequalities. That's where it gets challenging. Well, more challenging, I should say. The absolute value of x less than 2, let's say. Less than sounds like and, than, and the and sound is sandwich. This means -2 is less than x less than 2. If you're not sure, check values. Is x equals 0 in it? The absolute value of 0 is less than 2. Yes. So we do have in between. Is less than -2 work? -4. Absolute value of -4 less than 2? Nope. And outside of 4 is the absolute value of 4 less than 2? No. So it's the in-between thing. So I've got -2, 0, and 2. Recall when we don't have the equal portion on the inequality, these are hollow points. And in between goes between them. These type of problems occur frequently. These scenarios come up in real life, I should say. When we're looking at things with a margin of error. And I'll give you an example in a little bit. And as a reminder, we just saw this in the last section. If we have something like this, we have absolute value of x is greater than 2. Greater or greater sounds like or. The or sound gives us 2 regions. And this is x is greater than 2, or, and then we do, remember we have 2 or -2. When you do the -2 one though, you got to change the sign. That's what happened up here too. X is less than 2, or X is greater than -2. But when we put them together, those two make that. When you change the number to negative with an absolute value, you change the sign. Okay? That's the trick. But this is going to be -2 to 0. And now we're going outwards. 2 regions. Okay? Let me give you an example where this applies. Something you're familiar with, everyone's familiar with. The average human body temperature is 98.6 degrees Fahrenheit. And a healthy region around this is within, let's say, 1.2 degrees, 1.2 degrees Fahrenheit. Or a margin of error of 1.2 degrees. What this means is I want the difference between my temperature and 98.6 degrees to be less than 1.2 degrees. I can be above it or below it. And still be fine. I think 1.2 might be a little bit high, but I just made this problem up right now. How does this convert to an algebra problem? I want my difference either below or above. Difference is, let's say my temperature is T. I want the difference between my temperature and T, or my temperature and 98.6 degrees. It can be above or below, gives you an absolute value. I want that difference to be less than 1.2 degrees. This is an and scenario, less than and. I can do -1.2 degrees less than T minus 98.6 degrees less than 1.2. Add 98.6 to both, all sides, all regions. (97.4 degrees is less than T is less than 99.8. I think 1.2 was a little bit high. I think if I was at 99.8, I'd probably getting close to running a fever. Maybe 1.2 is too high, but above this is a fever. And below it, you've got the chills. You're too cold. So that's what I mean by these types of problems come up in real life, margin of error. Let me give you guys one to, let's do some more. So let's just do an equality one first. We've got 9 minus 4x equals 7. I gave you all the rules. I gave you a scenario where this shows up in real life. Let's look at, I just set paper on some water. That's lame. Condensation around the cup. All right, 9 minus 4x, the absolute value equals 7. So 9 minus 4x equals 7, or 9 minus 4x equals negative 7. And we solve both of these. Negative 4x equals negative 2, or negative 4x equals negative 16. Divide by negative 4. Don't forget to divide by the negative 4 part. X equals 2 over 4, which is 1/2, or negative 16 divided by negative 4, x equals 4. Okay. Harder. Let's go harder. Let's do 2 absolute value signs. Absolute value of 3x plus 2 equals absolute value of x minus 5. We still got to do the plus or minus thing. And it doesn't matter which way you do it. Oddly enough, option A, 3x plus 2 equals positive x minus 5, or 3x plus 2 equals negative x minus 5. Option B, we could leave the right side positive and make the left side either positive 3x plus 2 or negative 3x plus 2. Now, it's easy to see the top ones already match up. These match already. If I multiply both sides by a negative, by -1, let's say, negative value, it just makes the right side positive, gets rid of the negative there, makes that x minus 5, and it makes the left side, everything on it changes sign, makes it negative. So those two are equivalent. Also, so it's usually easiest to do option A. Most people go with option A. And that's what we're going to do. So pause this if you need it up longer. I'm going to rewrite what we got on the next page. Well, actually, let's just rewrite the problem. And I'm going with option A, where I leave the left side positive and I change the right side. And make sure you put, when you do the -1, you put it in parentheses, because you need to distribute that negative sign. We got 3x plus 2 on the right equals negative x plus 5. And this one is still the 3x plus 2 equals x minus 5. In both cases, I'm going to gather x's on one side, and I'm going to move the constants to the other. So 3x minus x is 2x, and then 2 minus 2 is 0. That's my left side. Right side, x minus x is 0. Negative 5 minus 2 is negative 7. Divide by 2. and I get x equals -7/2, or x equals -3 1/2. Over here, add x to both sides to get the x's together, and I'll subtract 2 from both sides, get all my constants together. 3x plus x is 4x, and 5 minus 2 is 3. If I divide by 4, I get x equals 3/4. Those are my two answers. Okay. Let's go back to doing the inequalities. That was just some equality work. Absolute value of 4x minus 6 equals, or is less than 10. Remember, less than is the sandwich. So why don't you go ahead and try to solve this? And write it in interval notation. Solve, graph, interval notation. So the sandwich, we can do -10 on the left and +10 on the right. Add 6 everywhere. Get -4 is less than 4x, less than 16. Divide by 4. I get -1 is less than x is less than 4. Graphing that. Between, so I've got my things that look like headsets. They're hollow points, so I'm going to use parentheses, and it goes from -1 to 4. Let's take a look at a +1 real quick. Absolute value of 2x minus 5 is greater than 5. Why don't you try solving that one? Remember, greater or is going to lead to 2 regions. So I'm going to have 2x minus 5 is greater than 5, or 2x minus 5 is less than -5. I add 5 to both sides. I get 2x is greater than 10. Divided by 2, x is greater than 5. Or I add 5 to both sides here. 2x is less than 0. Divide by 2, we get x is less than 0. Less than 0 is to the left. Greater than 0, or greater than 5 is to the right. In interval notation, we've got -infinity up to 0 in union with 5 to infinity. And just as a reminder, recall if it's 2x minus 5, if we had the greater than or equal sign, this would be x is greater than or equal to 5, or x is less than or equal to 0. Same plots, but now we have solid points. One, two, three, four. And when we do interval notation, the infinities still get the parentheses, but our points that are solid points get brackets. This is a relatively short section. I've only got a little bit more to talk about. It's important to note, if the absolute value is not isolated, is not alone, you must isolate it before solving. For example, if I have the absolute value of 5 minus 8x plus, that's the absolute value of 5 minus 8x, and then plus 6 is greater than or equal to 14, do not say absolute value of 5 minus 8x plus 6 is greater than or equal to 14, or the absolute value of 5 minus 8x plus 6 is less than or equal to negative 14. That's wrong. Absolute value of 5 minus 8x plus 6 greater than or equal to 14. Get the absolute value alone by subtracting negative 6 or adding negative 6, subtracting 6. I get the absolute value of 5 minus 8x is greater than or equal to 8. And now we can solve. Absolute value of 5 minus 8x is greater than or equal to 8, or 5 minus 8x is less than or equal to negative 8. Oop, I don't need the absolute value there. My bad. Subtract 5 from both sides. Negative 8x is greater than or equal to 3. Subtract 5 here, I got negative 8x is less than or equal to negative 13. So x is greater than or equal to negative 3/8, or x is less than or equal to 13/8. Hold on. Did I do this wrong? Oh, when I divided by a negative, yep. Divide by an, I knew that was wrong. Divide by a negative, switch the inequality. That was wrong. Dividing by negative 8 makes it x is less than or equal to negative 3/8, or x is greater than or equal to 13/8. There we go. Now we have two regions. I could tell where I was going, that this was going to end up being between greater than negative 3/8 would be that way, and less than 13/8 would be that way. That was an and scenario. I recognized by the way I did it that I had it wrong. I made a mistake. All right, so in all these scenarios that we've done so far, my right side has been positive. So far, the absolute value has been positive. So far, the right-hand side has been positive. And that has led to two solutions. or two inequalities. This is a little bit different. If it equals 0, the right-hand side, RHS for right-hand side, is 0. What happens? Like 7x plus 28, and absolute value signs equal 0. If I say plus or minus, I dump the absolute value signs, 0 is just positive or negative, is still just 0. 7x equals negative 28. X equals negative 4. Divide by 7. Just one solution when right-hand side is 0. And what about if the right-hand side is negative? If I have x minus 2 is less than negative 2, well, start off. X minus 2 equaling negative 2 never works. So if we do the equal sign, there's no solution. The left side is positive. Absolute value is positive or 0. And the right side is negative. A negative number does not equal a positive number or 0. Again, this is a positive number ever less than a negative number? No. So the less than version gives no solution here also. If we have the greater than sign, well, here I've got a positive. The left side is positive, is greater than a negative number. This is true no matter what x is. So x can be any real number. X is in R. And what that means is this means either if the right-hand side is negative, there's either no solution, that's for the equals or less than case, or an infinite number of solutions, and that's for the greater than case. All right, that wraps up 1.8. Short section, right? Incredibly short section. The harder part is 1.7, of all those inequalities, getting used to them. This gives you more practice, which is good. Peace. Take care, guys.